Well, sorry to disappoint. My name isn't Shruti. I'm Kevin here today. We did have to change things up a little bit because the talk, the hardest things about vector search, that was actually moved to an 11:30 talk. So hopefully you caught that. And if not, do come visit us at our booth later, and we can share that with you. But I'll talk about a different topic today, which is the next generation of search, our perspective on that, and how that intersects with AI, given that this is the AI conference. So let's move along. But perhaps it's helpful to back up a little bit to give context for our topic today, which is, Rockset is essentially a search and analytics database. What that means is that a lot of our users use us for use cases like real-time personalization or anomaly detection, things like that. And what's key in these cases is really low latency queries. They need queries to complete in the millisecond range, oftentimes with high concurrency at the same time. So what we do to support all of these use cases is to index all the data, and that's how we deliver performance at the end of the day. So we started out, before vectors and before that with a converged index. And let me explain to you how this works in Rockset. So we put everything that we ingest into a converged index, and the converged index borrows from multiple ideas. The inverted index you might be familiar with, right, for text search and things like that. A column store, which we use for large-scale aggregations, and a row store, which we might use for projections, right, when you have a document ID and you need to fetch the rest of the values for the document. So everything we have is indexed in multiple ways, and the Rockset Query Optimizer really just chooses the right index for your query depending on how selective it is. So for example, in the slide, if you have a selective query, it might go for the search index, or if you have a large scan, the engine might pick the column store instead. And so all of this, the converged index is stored on RocksDB, which is a mutable database under the hood. That's our storage engine, which allows for fast ingest and updates and so on. So that's all about the performance underpinnings, why we index, how we index. And now we get to vector search and approximate nearest neighbor and building ANN indexes. Now, why did we add ANN functionality to our converged index? We think that there are very good complementary ideas and complementary things here. So on one hand, you have converged indexing, which is great for the exact matches that we were doing, filters, aggregations, and so on. And ANN, along with vector search, that's obviously what you need for things like semantic, similarity search. So bringing these two ideas together might be, we might do so in a query like that. Like, this is something that Rockset enables our users to do, which is having a vector search, like show me all the restaurants I might like, right? So that's going to be the vector search portion of it. And I want to do some aspect of metadata filtering alongside that are located within 10 miles of me and low to medium price. So these are the types of queries that we want to power with good performance, and our indexes would, the converged index together with the ANN index would serve this sort of query. All right, so with that, how do we go about building an ANN index into a converged index? First off, we go out and choose, what type of algorithm we want to support. So we've chosen the FEISS library for this, and how this works is we actually divide up the vector space into multiple cells, right? And each cell is defined by a centroid, which is the center point of that cell. And we're going to fit our vectors into each cell depending on how far they are from the centroid. So again, the FEISS library assigns vectors to a Voronoi cell, and each cell will be defined by a centroid. So that's conceptually what's happening. And so what do we do with the converged index? How does this work for you as a user? What you would do is you would create a similarity index. This is stored in memory You would specify, for example, if I want 1,000 cells in my similarity index, it would create 1,000 cells along with the associated centroid values and cluster data in, in these cells, depending on how far they are from these centroids. So that's the first step in adding ANN to our converged index. And the second step that we actually perform under the hood is, as we store these indexes in RocksDB, what we're doing is, we take the embedding and we come up with the centroid and the residual for each embedding, and we store them as hidden fields in our index. So for every record that has an embedding, we will store centroid along with the residual, which will tell us which cell it belongs to and how far the vector is from the centroid. So that's how we store in our converged index when we've added this ANN functionality. All right, so now we get to the query stage. We've stored this in our index, and one side note here that we've designed into Rockset is that we actually separate out, with the ability to separate out like your ingest and indexing compute from your querying compute. So you can isolate these, the compute resources for both, such that they don't conflict or with one another, right? You can ingest heavily at the same time as you are querying. So for example, the query we might ask might be something like that. We want to look for certain folks, name and age, that are in a certain location, and we want to do a similarity search where we are ordering by a dot product here. Okay, so that's the query that we would issue to Rockset and the converged index, and the query optimizer essentially translates this into a query like that, where it would look for the centroids that are closest to the query embedding and say, okay, these 3 centroids are closest to the query embedding. I will use that to limit my search to these centroids, which now gives us the ability to reduce the time and the resources needed to perform such a search, right? So our indexing benefits this query. And then the one last thing to note is also, as we have as we store the centroids and the residuals, Rockset is a mutable database, and so it's very useful for when you have real-time data that has real-time updates. We commonly ingest from streams from Kafka or Kinesis or other streaming platforms of that nature, and oftentimes there are updates that happen in the database. And actually, one thing that one constraint that many of our users have on Rockset is that, hey, we need you to be able to have data show up within 200 milliseconds or 100 milliseconds in my index and be ready for queries. And because RocksDB is the underlying storage engine and it gives us this mutability, once we update the vector embedding in our record, the centroids and residuals will automatically change and update, and you'll be able to query the new information and new data within several hundred milliseconds, usually. So again, the steps here, you update the vector embedding, we go out to Feist to generate the new centroid and residual, and then Rockset will automatically update this in your record. So with that, I think I've kind of talked about the motivation for why we are doing, ANN indexing, similarity search, alongside with traditional data formats like JSON, geodata, time series data. It allows you this ability to merge vector search alongside other metadata filtering that you might do. That's certainly one thing that a lot of our users require of us. And then secondly, the ability to do real-time updates is something that has been differentiated and something that our users have come to expect from Rockset. So if this is something that's interesting to you, do come to our kiosk. We're outside there, and we can talk more about your use case and answer your questions.